Okay, so how do we use rocks to tell the history of the Earth? That's pretty tricky, and this is the topic of a chapter that we'll spend a lot more time with later on in the second unit called, Discovering Earth's History, or how we discover Earth's history. But today, I just want to talk about a guy named James Hutton and an idea called uniformitarianism. Now, this is going to sound really oversimplified, and I'm not oversimplifying it. This is really what the idea is. Uniformitarianism is just the idea, and we'll talk about the development of this idea later, but it's really just the idea that rocks could be interpreted because we can actually read the rocks, because we can look at places today where similar rocks are being formed and then deduce or assume perhaps that no matter how old that rock is, it was probably formed from a very similar process as what we see today. Basically, the present is the key to the past. This is going to seem really obvious to us, but this is a big deal because back when people were only looking at religious texts, not just the Bible, that people call chronologists, kind of scientists back during the 1700s, 16, 15, going way back, medieval times even, we're trying to figure out not only when did the Earth form and how did it form, but also when is it going to end. They were just as interested in that idea, which obviously we don't have an answer for, but they were trying to figure out how did the Earth form, when did it form, and yeah, they were using different stories in the Bible. Actually, there's like at least 2 different creation stories in the Bible itself, but then there's many other texts, and once China opened up, oh man, all sorts of information. So there are these people in Europe are trying to figure out with all these texts, when did the Earth form and how. Well, problem is that human stories are not going to tell us about how the Earth formed or when. We're going to need to look at things because eventually it was determined that, okay, kind of looks like the Earth has had a history that predates humanity. That was a really uncomfortable thought for a lot of people. Predates humanity by a lot. They started to look at, okay, well, if we can't look at human writings and our own words, our own experiences and beliefs, what are we going to look at? It was really James Hutton who came up with the idea of let's look at the rocks and let's start to look at the rocks as though they are showing us a record of our history. They didn't just all form at one time from a big catastrophic event like a god creating the earth and doing all this stuff. They formed over a period of time, perhaps a very, very long period of time, from the same slow processes we see on our earth today. And he was right. And actually, that's why he's kind of considered the founder of geology, because without this, we couldn't do geology at all. The old biblical or catastrophism idea would be just like, oh, if you hold a rock, oh, big flood, big catastrophic flood, or God was angry and did this. Things that we don't really see happening today formed this rock. All right, well, then we can't study the process by which that may have happened, right? Geology allows us to take a rock and think, oh, well, this looks a lot like this process, like a river depositing sediment or a lava flow, creating this hard black rock. Then I can say, it doesn't matter how old this rock is, I could deduce that it formed from much the same process. So I could study this modern day process, maybe even, create this situation in a lab and figure out exactly how this rock formed. And that's a huge deal. And this is going to take us a whole semester to kind of delve into and think about it. Maybe when you're in bed tonight, you'll think about it and be like, wow, that's really deep, because it seems so easy. But he came up with this idea that read the rocks, because our books aren't going to tell us. So Charles Lyell popularized this idea in 1830 because Hutton was not a very good writer or a very good science communicator. But Lyell kind of took it a little bit too far, insisted that all geological change was very slow and gradual. But we know that's not the case. We have violent volcanic eruptions. We have violent earthquakes, like we just saw in 2010 in Haiti in the previous video or so. We have meteor impacts that happen with some frequency on our planet. We have what we would consider on a human time scale and affecting humanity, catastrophic things. But they fit into this idea of uniformitarianism because they do shape the rocks. They create and deform rocks today, and they have always done. So they, these catastrophic events to us, to humans, are also a part of uniformitarianism. So this idea, this uniformitarianism idea, also sometimes called actualism, allows us then to take a very old rock, like this looks like a sandstone with ripple marks, and look at a modern day place where sand, loose sediment, loose sand, is being formed into ripple marks by wind or water. And then we can look at this ancient rock that maybe is in a completely different environment than it was millions of years ago when it was formed, and say that, oh, maybe, it formed from the same process. We could even figure out the direction the wind or the water was going in, or the speed at which that fluid was moving in, all sorts of things. We could definitely do this sort of thing in a lab. We can also kind of do this in a lab too. We could see a modern day lava flow, like in Hawaii, and see an ancient rock that looks very, very similar to that modern lava rock and think, boy, this rock could be 1 billion years old. And we could still say, I bet that formed from a volcano because it's so similar to our modern volcanic rock. And I know you guys are hearing this and you're like, well, duh, that's kind of obvious. But it wasn't until like less than 200 years ago when geologists made this connection and began to pull away from these catastrophic or supernatural stories talking about how rocks formed and gods being mad at each other and huge flood, unlike anything that we've ever seen or can study in modern history. Yeah, floods occur, but they leave behind the same kinds of sediments that floods today leave behind. We can see that, and we will actually. The history of flooding or sea level rise and fall all throughout Earth history is just an information bomb. It gives us so much information into different things on our planet, including climate, which is very cool. So anyway, but understanding how these things happen today is key to understanding how those ancient rocks formed. So we're reading the rocks. And so this is kind of an image I found online that's kind of good. I think it's kind of snotty though. Oh, what I see versus what you see. Well, this is what you will see. And this is my job, is to help you see that, yeah, the rocks are pages of a great history book, probably the best history book, but we have to learn how to read the rocks. And that's what chapter 2 is all about. So thanks, guys. This is stuff that obviously I get really excited about. And, so go ahead and watch the video about James Hutton and why he was so cool. And we'll be talking more about him later, but we're just doing a big kind of introduction to many, many different important topics, kind of creating a foundation, if you will, for how we're going to deal with the rest of this material this semester. So thanks a lot, and I hope you enjoy the textbook as well.